Okay, so now what I'm going to do is show a review of what the IRQ handler for the FIR filter is going to look like, right? And this is just a flavor for what it is. We'll look at the detailed driver in a moment, and then we'll go and see what it actually looks like in terms of the demo, right? What does it actually mean to do something of this sort? So as you can see, this IRQ handler, this is the tasklet or the top half code, right? What it's doing is it needs to check that I got an interrupt, that the interrupt was actually because the filter was done, clear the status. Now take the spin lock, set a particular variable to be true, and then unlock it, right? So the spin lock actually is happening in a very, very narrow context. All that it's doing is changing this particular value of f dash done, right? And as we'll see later in the code, this actually is used by us because this can be used in order to say, okay, I can wait on this and use that in order to decide whether to proceed or not. Now, having done all of this, it basically says, okay, wake up interruptible. So it's not sort of explicitly calling something as a bottom half. It's not scheduling work to be done later. All that it's doing is basically changing the status of one particular flag and then saying, okay, wake up the interruptible routines out here, and then say return IRQ handled. So if you walk through this, you can pretty quickly say that, yeah, there's nothing that is unreasonably long over here, and therefore this looks like a reasonable IRQ handler. In the context of the FIR filter, what we are going to do, right, what we are going to see in a moment is, we will basically write the coefficients in input, then start processing. And then, as I'll show you, you can basically call the read function, where I'll basically try to read from the FIR filter output, and it will block, okay. Eventually, at some point in time, the IRQ signal will assert. It will say, okay, it's done, right. And once that is done, the filter, right, the read function will wake up. It needs to copy the data out from where it is, and it can basically be used in order to see the results, right. So these kind of things which, the wait event, essentially what I'll be doing is I'll be waiting for this FIR done value, right, which, like I said, will only get atomically set inside the IRQ handler when the IRQ actually happens. Okay, so now this is the driver code corresponding to the FIR filter, right? And what I have done in the case of the FIR filter is this is essentially the same FIR code that we used in the week 7 videos, right? I have a driver which allows me to update the coefficients, write data. As and when I write data, the length gets automatically computed and updated inside the filter. And eventually I can sort of write a start value into the control, which will cause certain parameters, certain signals inside the hardware to get set. And once they are set, it will basically sort of spin over there until it has completed the computation, right, at which point the done signal will be raised. The only additional thing that the change that we made in the hardware is that now that done signal is taken as an FIR IRQ out. In the very later co-simulation, I have basically mapped it such that IRQ out is mapped appropriately. In my Renode platform description, I have set up that IRQ out to be connected to one IRQ, right? We can basically look at that. What we can see over here is the way that I have connected it is I have now connected the FIR IRQ signal to the GIC number 34, right. 33 was used for the shared peripheral interrupt, 33 was used for the timer, 34 is being used for my filter, right. Why did I choose 34? Well, it's the next number, that's all, right. So I can pretty much choose anything which has not already been assigned to something else. The important thing is I need to know the rest of my hardware. If there is something else which has also been assigned to the same IRQ number, I can potentially end up with multiple drivers trying to register the same IRQ and running into problems with that, right. So as long as I give it a separate number and it's been connected up properly, this is fine. So I just choose 34. So let's go back to the driver. Let's look carefully at it, right. What we have over here is once again the driver by itself defines its data. It defines a bunch of locks, right, a couple of different locks over here. What we can see over here is that there is one lock for the coefficient writing, which is a mutex, because as we will see, this is never going to be taken inside the IRQ handler. But there is another status lock which is a spin lock, because that is something that I am going to be using inside the IRQ handler in order to update the done signal, right. And this processing and done signals that we have over here are just something to indicate that what is the current state of my system, right. So as we will see in a moment, I mean, this is just more for convenience, right, to sort of say, okay, I can just directly look at these values and see in what state they are. But by putting a spin lock on it, I can make sure that this done signal gets updated in a clean way, which allows me to transfer control from the top half to the bottom half, right. I have some coefficients, I have a length variable, I have the current position of the inputs and so on, right, and yeah, the rest of it is basically there. So my IRQ handler looks like this. I make sure that it actually was an interrupt based on the done signal from the FIR. I clear the interrupt, take this spin lock on status and set both the done and processing to their appropriate values. In other words, done is set to true, meaning that I have completed the filter processing. Processing is set to false, I have completed the processing. And then I do a wake up, right. So I am not calling a function, right. So the wake up interruptible is in a way one method by which I can basically say this is how I am scheduling my bottom half, right. In this case, I am actually not scheduling any separate work to be done, right. What I am doing is that I have got this interrupt. There is no work to be done after the filter has completed. I just have to wait over there and say, okay, now somebody wants to read out, right. I could have something else where perhaps I could change it in another way, where I could instead have a mechanism where once I have got enough data coming in, it generates another kind of interrupt which says, okay, now the buffer is full. And the IRQ handler for that interrupt might have been something which basically says, okay, now go and start filtering, right. If so, then I would basically defer that as the bottom half of my work to be done. Right now the bottom half is sort of implicit, it is just I wake up anybody who is waiting for me. Now we also have the FIR open and FIR read. As I said, this is just to provide the character device, right, which allows me to sort of read out the data once it is done. And this is the crucial part, the read operation will essentially block on this done signal, right, and it will wait for the done signal to come from the interrupt handler, okay. And once it comes, the rest of it is fairly straightforward, it just sort of reads out the data and prints it out. After it has done everything over here, it clears the done signal, right, because this is sort of useful for the system. This is an internal sort of mechanism that we have over here which just helps us to make sure that this done signal can be used inside my driver, because after all this done signal never goes back to my hardware, it is used only inside the driver, right. But it helps me to keep track of whether I am in the middle of processing something or whether I have completed whatever was expected to be done. Why do I put a spin lock over here? Because during this time that I am actually doing this, what if an interrupt came along, right. So while I am changing the value of FIR done to false, I do not want the interrupt to come and set the FIR done to true, right. By putting a spin lock over here, I have managed to guarantee that. What I am saying is, even if for some reason this function was pretty slow, it was taking its own sweet time and an interrupt came along right then, right, I am not going to go in there and clear it until I have actually managed to, the interrupt has actually been handled, right. Okay, so then we have all the sysfs attributes and so on, the same as before. This is no different from what it was earlier, so I am not really going to get into detail on this, right. Once again, I have already compiled the kernel with the driver in place, so we are straight away going to go and run the Renode example.